Okay, let's jump right in. Have you ever wondered how AI solves problems that are just impossibly huge? Problems so complex that finding the single perfect answer would take forever? Well, today we're diving into the secret world of intelligent search, the clever shortcuts that make modern AI possible. To really get this, I want you to picture something. Imagine you're standing in front of a massive mountain range, and the whole thing is blanketed in a thick fog. Your job is to find the absolute lowest point, the deepest valley. The problem? You can only see a few feet in front of you, and walking over every single inch of that terrain is just not an option. It would take you thousands of years. So what do? This foggy mountain problem isn't just a riddle. It's actually a perfect metaphor for the kinds of challenges that scientists and engineers tackle every single day. We're talking about things like figuring out the most efficient delivery route for 1,000 packages, or finding the perfect combination of chemicals for a life-saving drug. In these cases, checking every single possibility is totally out of the question. It's just computationally impossible. So, how do we navigate that fog? This is where a brilliant idea called metaheuristics comes in. Now, that's a mouthful, I know, but the concept is actually pretty simple. Think of them as high-level strategies or intelligent rules of thumb. They don't promise to find the one single perfect solution. Instead, they're designed to find a really, really good solution, a good enough one, in a practical amount of time. And this really gets to the heart of a huge trade-off in computer science. On one hand, you have exact algorithms. They will, without a doubt, find you the absolute best answer, guaranteed. But they're so slow, they're often completely impractical for real-world problems. On the other hand, you have metaheuristics. They give up that guarantee of perfection in exchange for speed. They'll find you a fantastic, near-optimal solution, and they'll do it fast enough to actually be useful. It's all about practicality over perfection. So where do we get these amazing ideas? Well, it turns out we often get them by looking at the best problem solver around, nature, right? After billions of years of trial and error, the natural world has come up with some incredibly clever and efficient shortcuts. And some of the most powerful metaheuristics are inspired directly by these natural processes. And these strategies, they share some really cool traits. First off, they use randomness in a really smart way. A little bit of chaos helps them jump out of small valleys and explore new parts of the landscape so they don't get stuck too early. They also get better over time. They learn and improve their solutions as they go. And maybe the best part is that they're super adaptable. You can take the same core strategy and apply it to a whole range of different problems. So let's think of these different metaheuristics as unique search parties. Each one is a team we can send out into that foggy mountain range. And each team has its own unique strategy for exploring the terrain and finding those low points. Our first search party is inspired by probably the greatest problem-solving process of all time, evolution. Evolutionary algorithms are basically Darwin's survival of the fittest turned into a computer program. You start with a bunch of different potential solutions, and then you let them compete, combine, and evolve over generations, with the best ones surviving to pass on their traits. The classic example here is the genetic algorithm. Here's how it works. First, you create a whole population of random solutions. Then you test how good each one is and select the fittest of the bunch. Next comes the fun part. You combine the traits of the best solutions, this is called crossover, to create new offspring. And finally, you throw in a few random changes or mutations, just to introduce some new ideas into the mix. You repeat this cycle over and over, and with each generation, your population of solutions gets better and better. Okay, our next search party gets its inspiration from the amazing things that groups can do. Swarm intelligence is all about how simple individuals, like ants in a colony or birds in a flock, can work together to achieve incredibly complex goals, all without a leader telling them what to do. It's decentralized teamwork at its finest. You'll see a couple of really popular strategies here. One is particle swarm optimization, or PSO. Imagine a flock of birds searching for food. Each bird remembers the best spot it has found so far, but it's also influenced by the best spot the entire flock has found. It's a balance between individual and group knowledge. Then there's ant colony optimization. Here, digital ants wander around and leave behind a trail of digital pheromones on good paths. Other ants are attracted to stronger trails, which quickly reinforces the shortest, most efficient routes. So cool. And the inspiration doesn't even stop with biology. Other algorithms borrow ideas from physics. For instance, simulated annealing mimics the process of slowly cooling a piece of metal to strengthen it. The algorithm starts out making big, random jumps when it's hot, and then gradually cools down, making smaller and smaller adjustments to fine-tune a final stable solution.
All right, these ideas are fascinating, for sure. But here's the kicker. This isn't just theory. These intelligent search strategies are the secret sauce behind some of the most powerful AI systems we use every single day.
For example, every machine learning model has tons of little settings or tuning knobs called hyperparameters. Finding the perfect combination of all those knobs is its own massive foggy mountain problem. And guess what we used to solve it? Metaheuristics. They automatically search through all the possibilities to tune that AI's brain for peak performance. But it gets even wilder. Using a technique called Neural Architecture Search, or NAS, we can use these algorithms to act as automated architects for AI. I'm not kidding. They can literally design the structure of neural networks from the ground up, discovering new and powerful AI brains that sometimes outperform anything a human expert could dream up. And this right here is totally cutting edge. Researchers are now using metaheuristics for prompt engineering. They are evolving the instructions we give to large language models to get better answers out of them. Think about that for a second. We are literally using AI to figure out how to talk to other AI more effectively. And we're not talking about tiny improvements either. The source material for this explainer pointed to a case where a clever implementation detail led to a massive 10-fold speedup for one of these algorithms. That's the kind of leap that takes these tools from being a neat academic idea to a game changer in real-world science and engineering. So what's next? Where does all of this go from here? Well, the field is moving incredibly fast, and the search for even smarter search methods is always on. And for anyone out there wondering which tool is right for which job, here's a quick rule of thumb. If your problem is a smooth, continuous landscape, something like particle swarm optimization is a great bet. If it's more like a puzzle with discrete pieces, like a scheduling problem, then genetic algorithms or ant colony optimization really shine. And for those super tough problems where every test takes a lot of time or money, you can even use a helper model to make the search more efficient. Looking to the horizon, things get really exciting. We're starting to see new quantum-inspired algorithms emerge and deeper connections being built with other areas of AI, like reinforcement learning. And there's a huge push to make the search process itself understandable, to build explainable AI so we know not just what the best solution is, but why it's the best. That's absolutely crucial for building trust in these systems. And that really brings us full circle. This quote from the source material just nails it. In our messy, complex world, the winning strategy often isn't about a slow, painful crawl toward perfection. It's about having smart, agile, and intelligent ways to find really good answers fast. So I'll just leave you with this final thought to chew on. From planning your next big project to just organizing your week, we all face our own foggy mountain problems. So what's a complex challenge in your world that doesn't need a perfect, flawless answer, but could be completely transformed by an intelligent search for a great one?